In one of your homework assignments before your test, which by the way, I'm still grading the tests. So my goal is to get them finished grading and put the progress reports in and send out the progress reports as soon as I can. So thanks for your patience. When we had a homework assignment before the test, we asked you to do a perpendicular bisector for each side of the triangle. Do you remember the holy cow wow moment? What happened? Yeah, they all intersected at one point, and there was a point of concurrency. And then we did it with angle bisectors, and we had another holy cow moment because what happened? They all intersected at a point of concurrency. So what I would like you to do is I'd like you to do those 6 constructions, 3 perpendicular bisectors, 3 angle bisectors for each of these triangles. I'd like you to take some notes on what it is that you're doing so you remember it for next time. And then if you look down here, we have now some official definitions of concurrent lines are lines that all intersect at one point, and that point that they intersect at is called a point of concurrency. Sound okay? So I'd like you to turn to your partner, and I'd like you to walk yourselves through this warm-up. Got it? Turn to each other and say, let's go. Let's go. Now that we've had some warming up time, I'm going to ask you to go back to the beginning of your first packet. So please take the first packet, construction packet, out. If anybody is in need of another packet, let me know. Because I want to go back and talk about constructions as a whole. When we first started constructions, we had this idea of what does it mean to construct. And did you get it?
Yeah.
Eugene, help?
No, I got it.
Are you sure?
Yeah.
Okay. And we started using this tool as a distance marker, for lack of better words. So when I measure how far away Z and R are, I can transfer that distance over to this new line, and I can know that no matter what, if I wanted to make this segment the right length, I can lock this distance in, it'll preserve it, and I can carry it over. That actually is more accurate than putting a numerical measure to it, inches or centimeters or whatever units that we're using. Because I'm locking that distance into this compass, I'm guaranteed to have exactly the same length when I transfer it over. The tools that we use for constructions are going to be our compass, our straight edges, and then with the straight edges we draw lines, segments, and rays. The interesting part about this is looking at this idea of the circle. And I love it when we think about a circle is not anything other than that path that goes around a point, equidistant from that point at all different places. Everybody thinks of the circle as including the inside and the center. The inside of the center, or the inside of the circle and the center of the circle are not part of the circle. The circle is only that path of points that goes in that arc around a singular point. And the compasses help us measure those distances, draw these arcs so that we can find intersections to create the figures that we're learning about. On the back of this page, you had conversations about and review of how to copy a segment, double and triple it, and how to make a perpendicular bisector. Hey, I love the perpendicular bisector. The game is in the name. It's perpendicular and it bisects. So anytime we talk about the characteristics of a perpendicular bisector, it evenly divides a segment into two, and it does it with something that creates that right angle, which is important. We learned how to copy an angle and create angle bisectors. You may have had the time to do this practice, maybe not, but what I want to focus on is these pages here where we talk about our parallel postulate and our perpendicular postulate. When I want you to think about something, when we all go to draw a parallel and perpendicular line through this point to this line, we are all going to draw the exactly same identical line. individually, because what this postulate says is through a point, not on a line, there is exactly one line that you can draw that is parallel to the given line. So what I want you to think about is go ahead and get your compass, have your straight edge, because we're going to do this construction together. The first thing that I want you to do is I want you to get your straight edge, and I want you to draw a transversal, and I want that transversal to go through this point that's not on the line. Now, I don't care how steep or flat your transversal is, and I don't care if you go from left to right or right to left. I don't care if it has a positive or a negative slope, but I want you to draw a transversal. Are you with me? Everybody with me? All right. So here's what we're doing. Pencils down and don't copy this. What we're doing is we're going to create a parallel line to this line, and we want it to go through this point. So what we have in the green dotted line doesn't exist except for in our imagination. Can you imagine that green line? Aren't you so good? Just imagine it, right? So that green line along with this transversal creates a bunch of angles. Call some out. What kind of angles? Corresponding? Alternate interior? Can, what? Transversal? Vertical? Alternate exterior, alternate interior. The ones that we're going to care about are going to be these ones. What are they? Corresponding, you're right. The corresponding angles, converse tells me if, what? Converse.
Oh.
If the angles are congruent, then.
Parallel.
And isn't that what I want to do? So if I can create two congruent angles that are in these positions, I'm going to get a parallel line. You okay with that? So that's exactly what I'm going to do. So I'm going to take away my imaginary conversations, and we're going to then copy this angle and put it up here. Are you with me? Get your compass, please, and put your sharp on your bottom vertex. Open it up to a comfortable distance, not too big, not too small. And draw, give yourself a working arc. Got it? Lock that distance in, tighten your screw up, because your next conversation is then going to be to transfer that working arc up to the next part of your angle. So put your sharp on the point that you're drawing the parallel line through. Now, I had to put mine in red because my transversal covered it up, but can you see the point that you're drawing the parallel line to? Through? And what you're going to do is you're going to draw another working arc. You're going to draw another working arc. The next step in copying an angle is to take your compass and you're going to measure how wide that working arc mouth is. So you're going to put your sharp at one intersection of the working arc, and you're going to put your pencil at the other. All right, once you get that measurement as precise as you can, draw an arc to say, I measured this distance and I'm locking it in. And then you're going to put your sharp back up to where your working arc intersects this top angle, and you're going to draw that arc again. So if I go back to telling you what we were planning, what we wanted to do was we wanted to find a way to make this angle congruent to this angle, because we wanted to draw a parallel line through that point. Look at what we just did. So you copied that angle, and then now you can take your straight edge and you can line up the point that you were drawing the parallel line through with your intersection of your working arc and the width of your mouth. You just copied that angle. That's how you draw a parallel line. We're relying on the corresponding angles converse, saying if two corresponding angles have the same measure, then those lines are going to be parallel. There's only one possibility. The minute you draw that parallel line, all of our papers now match, which is good. All right, here's the next construction. Through a point not on the line, there is one and only one perpendicular to the given line. So again, there is one and only one line perpendicular to that given line. So I'm going to make sure that I can figure it out. If I were to sketch where I think it's going to happen, it's going to go right through here at a right angle. Now here's the thing, I can imagine that, but it's a line, and I don't know how to get a perpendicular segment to a line. If I look in my bank of constructions that I do know how to do, I know how to copy a line segment, that's not going to help me. I know how to copy an angle, that's not going to help me. I know how to bisect an angle, that's not going to help me. But what else do I know how to do?
Copy.
Look through your constructions. What's the one I didn't mention yet? Copy a segment, copy an angle, bisect an angle, bisect a, yeah. I know how to do a perpendicular bisector. Remember, the game is in the name. It's perpendicular and it bisects. I want a perpendicular line. Let's make a perpendicular bisector. Here's the problem. You can't bisect a line. But you have the perpendicular bisector theorem fresh in your brain because you just took a test on it last class. And what that theorem says is any point on the perpendicular bisector is equidistant from the vertices, right? Right? Equidistant from the endpoints of that segment. So guess what you're going to do? You're going to give yourself a segment that you're going to perpendicularly bisect. See this point here? That's the end of your segment, and that's equidistant to the perpendicular bisector, as is this point here. So I don't have a segment, but I created one thanks to the perpendicular bisector theorem. I can go ahead and take my sharp and draw an arc under the line, switch it around, put my sharp on the other vertex, and draw an arc under the line. And if you'll notice, it matches up with what my imagined perpendicular bisector was when I match up the point and the arcs underneath. I just bisected that segment, nobody cares. It's just a segment I made up. Because I don't care about that. What I care about is the fact that it's perpendicular. And through a point not on a line, there is exactly one point. So that is how I draw a perpendicular line. Got it? Check in with your partner and see if they understand the parallel postulate and the perpendicular postulate. Check in with them. Go. You have these steps 1, 2, and 3 of the different constructions. A line segment congruent to a given line segment, a perpendicular bisector of a line, but now it's interesting, this one makes sense to us, where we have, a perpendicular to a line given from a point not on the line. Check out what they did here, they made their own segment, and then perpendicularly bisected that segment. That's all you need to do on that one. All right, let's talk about the rest of this packet. So when you look at the rest of this packet, let's go ahead and page through it. You should have already done the page before, the one that had the parallel and perpendicular postulate. So that was what we did on the day before Thanksgiving. The page after it is more practice doing parallel and perpendicular lines. Some of the descriptions are different from what the picture is, so just go with the picture. The next one I want to talk about is this one here, where we have a point that's on the line. So everyone get your compass out. Join me on this page. And I'm going to do one thing, and I want you and your partner talking about why did she do that? Turn and talk to each other. Why did she do that? Go. So just like I can't find the middle or the perpendicular bisector of a line, I can't find the perpendicular bisector unless the point that I care about is on the perpendicular bisector. So before, when we had the point floating up in the air, I made that on the perpendicular bisector to give me a segment to bisect. I just did the same thing here. This here is my segment that I'm going to bisect. I put my sharp on that middle point and said this distance is the same as this distance. So I drew an arc over here and here. So now this is the midpoint of this yellow highlighted segment. Nobody cares about that. I don't want the midpoint, that's not my goal, but I'm going to use the perpendicular bisector to give me a perpendicular line. Once I have my segment, I'm going to care about this end point and this end point, which is where I'm going to open up my compass more than halfway, mark above and mark below. I don't need to have above and below because I already have that point that I can then connect to have a line that's perpendicular to the line through a point. This is guaranteed to be perpendicular because it's a perpendicular bisector of that piece of the line right there. So whether the point is on the line or off the line, my first step is always going to be to draw an arc intersecting the line twice, one on either side, because that sets up that segment that I'm going to bisect, even if what I want is not the midpoint, but the perpendicular line. If you page through the rest of this packet, you have some more practices for you to work on, and this is going to be what you do during work time. Sound okay? Tuck this aside, and we're back to where we started with our warm-up. When you're constructing a perpendicular bisector for each side, I want you to include some notes here on what it is that you did. So you put your compass on your segment endpoints, which, if it's a triangle, is the same as the vertices. You measured over halfway, and you draw arcs above below. So what you should have on this triangle is constructions that help you find this midpoint, and this midpoint. You should have perpendicular lines, and they should all meet at a point of concurrency. When we're talking about angle bisectors, you should always start with your working arc and making sure that that working arc provides you with two intersections to draw arcs equidistant from your angle sides. So when you have these marks out here, that's what helps you draw that angle bisector. Now I'm drawing quick sketches, but I want you to actually do the constructions. When we hit our work time, if you didn't get to finish these, I want you to do them. Our definitions, this point of concurrency is a pretty holy cow wow moment. Matthew, put your head up. A pretty holy cow wow moment where I have three lines that all intersect in one space. If you don't get a point of concurrency, you screwed up one of your constructions, go back and fix it. Got it? Alright, next page. We're going to learn about two more segments. A median is a segment that is created from the midpoints of a triangle. So the first thing we have to do in creating this is going to be to find my midpoints of each side. So compass is out. Compass is out. And go ahead and put your sharp on one end point. Open up your pen to more than halfway. Draw an arc above and below. Lock that distance in. Go to the other vertex. Draw an arc from the other vertex and connect those points. Your perpendicular bisector tells you where your midpoint is. Matthew, join us. Pick up the tool. The cool thing about this is if you want to, you can use this same distance for more than one side. As long as it's more than halfway that's a good one. As long as it's more than halfway, because that'll continue to give you your perpendicular bisectors and your midpoints. Now I know our perpendicular bisectors meet and give us a holy cow wow moment, but that's not what we're going for today, because we're not talking about our perpendicular bisectors, we're talking about our medians. So when I draw these, even though I have all of these perpendicular line segments, what I really care about is the midpoint. The only way to get the midpoint is to do a perpendicular bisector. I don't care about those black lines at all. Are you ready for what I care about? You didn't see the holy cow wow moment yet. It's coming soon. I know. We're going for a holy cow wow. Are you ready?
Oh my gosh.
I'm going to do these segments in bright blue. Because by definition, a median is a segment that's created from the midpoint to the opposite vertex. So if I start at the vertex and put my straight edge, that blue is a median. The blue is the median, not the black line of construction. It's not a perpendicular bisector, it's a median, because it goes from the vertex through the midpoint. So when I'm connecting my midpoint to my vertex, I'm creating a median. And if you'll notice, your holy cow wow moment still happens, but it's not at the same point that my perpendicular bisectors are intersected. All right, let's take some notes on medians. When I'm constructing a median, I need to find the midpoint of each triangle side. And I'm going to use perpendicular bisectors as a tool for me doing that. My next conversation is where I'm going to connect your midpoint to the opposite vertex. Can you join us? The medians give you a point of concurrency, and that's pretty cool. Our next triangle side that we're going to make is called an altitude. An altitude is a perpendicular segment from the vertex to the opposite side. So I want you to think about a perpendicular bisector. The gain is in the name, right? It's perpendicular and it bisects. When I want a perpendicular bisector, I need the whole thing. When I want a median, I just need the midpoint. When I want an altitude, I want the perpendicular part. So those two parts of that segment, I use each one separately in addition to using them together. So for this one, if I want to draw an altitude, I need to draw a segment that goes from this vertex to this side. Now, unfortunately, so in order for my compass to work, I had to change mine a little bit. But this construction is going to be the one that we used when we drew a perpendicular from a point not on that line. Are you with me? Everybody take your compass and put your sharp on your vertex Open up your compass. Uh-oh, I wonder if I'm still not big enough. Open up your compass. I gotta make it smaller, hold on. All right, so you're gonna put your sharp on your vertex. And you're going to use your compass, you're going to make it so it's a little bit bigger than the length of the distance, and you're going to give yourself a segment to bisect. Now here's the hard part. Do you see how this segment that I picked is, I need to extend this side of this triangle in order to find my intersection. So here's my endpoints of my segment. If you need to draw it bigger, go ahead, because there's my endpoints of my segment that I'm going to perpendicularly bisect through this point. I'm going to bisect that segment. I'm going to put my sharp on each intersection. I'm going to extend my compass. I'm going to drag it out. It's stuck over there. I'm going to extend my compass so it's a little more than half. And I'm going to draw my arc above and below.
Wait, a little bit more than that?
A little bit more than half. Because I'm perpendicularly bisecting that segment I created. When I connect the opposite vertex through those points, I'm guaranteed to have a perpendicular line. If I can get it to stick. That's an altitude. If I repeat that construction 4 times, I'm going to get a holy cow wow moment because my altitudes. So all of these constructions are just versions of perpendicular bisectors. Finding the median, finding the altitude, etc. We're going to take some notes now on the different characteristics of each of these, and then you'll have the rest of the period to practice. All right? So join me for some quick notes. Are you ready?
I'm so excited. So much
Let's start with the sketch. When you have a triangle and you bisect each side with a perpendicular line, you end up with a holy cow wow moment of them all intersecting. The name of that center is called my circumcenter. The cool thing about my circumcenter is it is equidistant to your vertices. When I construct my circumcenter, my perpendicular bisectors are going to be constructed from your perpendicular bisector construction. That one's a duh. When I talk about my angle bisector, again, it's constructed from your angle bisector. Those points of concurrency of an angle bisector, that's called your in-center. And when we look at a triangle with my angle bisectors, when I bisect each angle, I end up with that point of concurrency. That point of concurrency is the same distance from each side of the triangle. Alright. When I talk about my medians, that's going to be where I connect my midpoints to my opposite vertex. So when I go to construct these, I need to find midpoint, and I do that through my perpendicular bisectors, and then I connect my midpoint and opposite vertex. The name of the point of concurrency is called the centroid. And the centroid is pretty cool because it creates a 2/3, 1/3 relationship.
Oh, you forgot to add the other E on the creates.
Okay. 2/3, 1 relationship on your medians. Meaning, if the length of this segment is 4, the length of this segment is 2. So 1/3 of the segment and 2/3 of the segment lengths. So if I had segment AC, if the distance from AC is equal to 6, 2/3 of that length is on one side, 1/3 is on the other. Now let's talk about altitudes. Our altitudes of the triangle are the height of the triangle. How we construct them is you find the perpendicular segment, and you do that through your perpendicular bisector. And then you connect the vertex to your opposite side. The name of the point of concurrency is the orthocenter. And this is always going to represent the height of your triangle, which we'll care about when it's time to find area. One of the other interesting things is if you have an acute triangle, your point of concurrency is inside of the triangle. If you have a right triangle, your point of concurrency is on the triangle. If you have an obtuse triangle, your point of concurrency is outside of the triangle. And that makes some funky pictures for sure. Our last triangle segment, we've already talked about. And that's your mid-segments. Not a point of concurrency. Not a point of concurrency, but it's worth mentioning because again, that's from my midpoints that I connect. How it's constructed is segments connecting my midpoints. How do I find my midpoints? Again, with your perpendicular bisector. The cool thing about these is 4 congruent triangles. A 1-to-2 ratio of mid-segment to your opposite side. And of course they're parallel. All right, that's a lot of notes. Let me tell you what your so what now what is. You have a pass, fail, all or nothing formative on this after you've had enough practice. We gave you a copy of the test. So take a look at your packet because the next 2 sheets are homework where you get to review, identify your pictures, and apply the relationships and knowledge. You don't need a compass to do this homework.
Do you need a compass to do the test?
Yes. Do you see these assessments in your packet? Do you see construction A? Construct a perpendicular bisector for each side. What point of concurrency did you create? List facts about the point of concurrency and facts about your construction. Page 2. Construct a median for each triangle side. What point of concurrency did you create? Facts about your point of concurrency and facts about your construction. Quiz C. Construct an angle bisector. Quiz D. Construct a mid-segment. Quiz E, construct an altitude. Look at that one. You get an acute right and obtuse triangle for this one. Construction F, a parallel through a point not on the line, a perpendicular through a point not on the line, and construct an equilateral triangle using circles. When you take this quiz, there are 6 different versions. You don't know which one you're going to get.
How many are one?
2. 2-sided quiz. You get 2, and it's a mix
I remember this.
of any of those.
So it's gonna be like just like this.
You're looking at your quiz. You're going to get 2 out of those 6 handed to you. So it's your job to practice until you know how to do them all.
And explain what's going
And guess how many times you get to retake this?
0.
As many times as you want. It's a formative. It either goes in as a 0 or 100. Got it? Guess how many times I had some kids take it last year?
on. 6.
10.
About half the class knocked it out in one shot. And about half of that class knocked it out, or half of what was left, knocked it out the second time. Half of that group needed another go. Half of that group needed another go. Half of that group needed another go. Just about every single time, half the kids knocked it out, and we kept going and going and going. I think I had one kid take it about 8 times.
Sounds like this kind of math problem.
It is like yeah.
Like list
Half and half and half and half and half.
physically-
All right, so the rest of the period is your work time. So your homework is going to be that 2-sided sheet that doesn't require a compass. I don't think you should work on that now because you can do that at home without a compass. I would go back to the first packet. Any constructions that you didn't finish need to be done. When you're ready, both of these packets will be turned in for a work habit grade. So I'm going to collect both of these. Would you take the time to put your name on both of them right now? Name and period 7. And know that I'm going to collect them at some point for a work habit grade. Sound okay? So if you need to go back to the very beginning and go back and do all your constructions, work on it, you have a good 30 minutes. And your mark is set, be productive, go.